Hi everyone, so we're going to start today with our outer planets, or another name would be our Jovian planets. Okay, so just some things to think about. Is Jupiter a failed star? What's Jupiter's red spot? Does Jupiter have continents and oceans? Is Saturn the only planet with rings? Are the rings of Saturn solid? Do all moons rise and set as seen from their perspectives? And here we're going to be talking about Jupiter as active, vibrant, multicolored, and it being the most massive than other planets, Jupiter's diverse system of moons, Saturn's spectacular system of those flat, thin rings, what Uranus and Neptune have in common and how they differ, and a little bit about Pluto and its moon Charon here. Okay, so again, looking at this chart right here, we're going to point out the important things here. So our average distance from the Sun, we have here 5, 2, so 52 million kilometers away from the Sun. Oh, sorry. It's actually 77.8 here. So 77 million kilometers away from the Sun here. Also looking at our rotation. So our orbital period here is 11.86 years. If we look also here of our gravity, we have a higher gravity on Jupiter. And if we look somewhat at our composition, this is also going to be important here to see the different types of materials that we can find in Jupiter here. So these are the key important things that I'm pulling out here. So one of the notable features on Jupiter are these bands. So our bands here are moving east to west, and you can see how these really differ between some white regions over here and our darker orangey regions over here. So against these backgrounds, these zones or belts are turbulent, spinning, swirling cloud patterns, as you can see here. Some swirling cloud patterns that we see on here. And this is going to be due to the range of how fast that Jupiter spins in comparisons to other planets, which is why we get these aggressive storms that form here. So our Great Red Spot is actually a huge typhoon storm that's been lasted for at least 300 years. And just this red spot could fit 2 Earths inside of it. So these cloud speeds on Jupiter vary within the latitude of the planet. So if we look here at our equator rotation, it's actually, the rotation time is 9 hours and 50 minutes, where at the top, it's 9 hours and 55 minutes. So there's 5 minutes longer of a rotational period for Jupiter's atmosphere than there is at the equator. So just because that difference allows those cloud speeds you can see here to have really aggressive storms that occur on Jupiter. So if we're looking a little bit at our atmospheres, here on Jupiter we can see that we start to decline, but when we hit these clouds right here, we have a really high temperature spike that occurs with that. But when we're looking at Saturn, we have a much less of a spike here in temperature. So the range here, as we're looking at this graph, is negative 160 to above 160 here degrees Celsius. So it's much varying here. So Saturn, since it has the lowest atmospheric temperatures, has a weaker surface gravity than Jupiter. So the clouds are more spread out. So that causes the temperature not to increase as drastically here. So astronomers believe that these belts and zones are created by a combination of the planet's convection and the rapid rotational speed. Rotation speed here. So convection is that temperature change that's going to make a big difference here, where and including in these very fast rotational differences. Though there is some evidence that says the temperature in the gases that kind of goes against that prediction here about the temperatures. But there's still a lot of evidence that we need to explore here to see more of a better pattern for Jupiter's temperature explanations. So it's believed that this comet, Shoemaker-Levy's collision with Jupiter, you can see it right here in these holes. And these fragments just exploded into large fireballs, leaving these dark spots that lasted for months here. So these fireballs were able just to cut right through the clouds of Jupiter and make those. You can also see on this diagram our red spot here. Remember, that storm is going to be a very famous landmark for Jupiter. So unlike some of our terrestrial planets, our Jovian planets do tend to have a lot of moons here. So we're going to take a look at some of Jupiter's moons right here. So if we look at our interior of Ganymede, we have our icy crust, we have an icy mantle, then we have another rock mantle and an iron core, where Callisto has that icy crust, maybe an ocean here in this layer, and a mixed ice rock interior. Io has a molten mantle, a rocky crust, and an iron core. Might sound a little bit familiar to Earth here. And then Europa has our iron core, a rocky mantle, an ocean, and an icy crust. So Io is the closest moon to Jupiter, and it's covered with many active volcanoes. So you can see a lot of lava flowing, and if we're looking at all these different dots and craters here, these are all different volcanoes. So these tidal forces from Jupiter and other Galilean moons keep Io's interior heated and keeping in that molten level, so we can see those volcanoes here. So Europa houses liquid water under an icy surface on top. So we can see some of these scars on the surface believed to be caused by rising warmed water. So looking at all these little scars here, can be believed that there's water underneath the surface here that's coming up. Ganymede is the largest satellite, so you're often going to hear moons referred to as satellites because they orbit our planets here. And it's even larger than Mercury, so this moon or satellite is larger than one of our planets in the solar system, which is pretty interesting. And our largest feature here on this moon is a huge dark rectangular region called Galileo Regio, which is just these deep furrows over here in this moon's crust. So this is going to be one of our statement features here. In Callisto, we have a huge asteroid impacts that you can actually see rings that were caused by this huge impact. And if we look a little closer, we see images containing both ice and dark material up on here. Some other objects that we see in the Jupiter system. So it has at least 59 other smaller asteroid-like moons. And these are 4 of these examples below. Some of these are also closer to Jupiter than its moon Io. We also can see some ringlets above that were discovered around Jupiter. So these ringlets, similar to Saturn, are around Jupiter, but much less prominent here. And we can also see regions of electrically charged gas particles called plasmas. So we can see these electrically charged gas particles coming around.